So let's talk about a technology that isn't just the next step up, it's a whole new staircase. I'm talking about quantum artificial intelligence, or QAI. And believe me, this is a field with enough power to solve some of our biggest problems, and maybe create a few new ones along the way.
All right, let's just jump right in with a wild question. Imagine a single piece of tech that could help us discover life-saving medicines in record time, but could also shatter the very security that holds our entire digital world together. That right there is the crazy two-sided coin of quantum AI.
So what on earth is quantum AI? I know, it sounds incredibly complicated. And yeah, some of it is. But the main ideas, they're actually more intuitive than you think. So let's break it down, nice and simple. Everything we use today, from your phone to a giant supercomputer, runs on what we call classical bits. A bit is super simple. It's either a 0 or a 1. Think of it like a light switch. It's either on or it's off. But quantum computers, they use something called qubits, and this is where your brain's going to do a little flip. A qubit isn't stuck being just a 0 or a 1. It can be both at the exact same time. Yeah? That whole both at the same time thing? It's a real phenomenon called superposition, and it's the secret sauce of quantum mechanics. So while a regular computer has to check possibilities one by one by one, a quantum computer, thanks to superposition, can check a mind-boggling number of them all at once. It's like, instead of trying one path in a maze at a time, you could explore every single path simultaneously.
Now, if superposition is a qubit superpower, then entanglement is what turns them into a super team. When you entangle qubits, you link their fates. Whatever happens to one instantly affects the other, even if they're on opposite sides of the universe. It's this spooky connection that lets them work together to perform these incredibly complex calculations that would just completely stump a classical computer.
Okay, so we've got this insane amount of computing power. What can we actually do with it? Well, the possibilities are kind of revolutionary. Let's start with the good stuff. All the amazing ways this could change our world for the better.
First up, finance. For Wall Street, QAI is a complete game changer. We're talking about running financial models that are just way too complicated for today's best computers. That means way smarter investment strategies, seeing risks before they happen, and building fraud detection systems that can spot tiny anomalies that are totally invisible right now.
But this goes so far beyond just making money. Think about healthcare. QAI could simulate molecules to help us find new life-saving drugs in a tiny fraction of the time it takes today. Or in energy, it could help us invent brand new materials for super-efficient batteries or design better solar panels. It could be a massive tool in the fight against climate change.
And this isn't just stuff for labs and trading floors. This tech will trickle down into our everyday lives. We're talking about self-driving cars that can make complex decisions faster and safer than any human. Or smart cities that manage traffic flow perfectly, in real time, eliminating traffic jams. QAI could be the powerhouse that runs this whole new, efficient world.
All right, we've seen the dream. It's pretty incredible. But like we said at the start, this is a double-edged sword. And with all that power comes a level of risk we have never, ever had to deal with before.
This chart right here says it all. You see that giant orange bar? That's how long it takes a normal computer to solve a certain kind of math problem that basically acts as the lock on our internet security. And that tiny little blue sliver next to it? That's a quantum computer. See, it's not just a little bit faster, it's playing an entirely different sport. The key that unlocks that problem is something called Shor's algorithm. It was actually designed way back in the 90s, just waiting for a computer powerful enough to run it. And once that computer exists, this algorithm can basically walk right through the front door of most of the encryption we use today.
And if you're wondering just how big a deal that is, think about this number. Around 90% of all the data we send online, your bank transfers, your private messages, everything, is protected by the exact type of encryption that Shor's algorithm was built to destroy. That's the foundation of all digital trust, and it's suddenly looking very fragile.
But the threat isn't just about breaking codes. The massive power of QAI opens up this whole new ethical minefield, raising all sorts of tricky questions that we're really just starting to think about.
Yeah, we are staring down a whole bunch of new problems. Could a QAI take existing biases in our society and amplify them on a scale we can't even imagine? What happens when this kind of power gets weaponized? And what about the environment? What kind of energy footprint do these things have? And maybe the biggest question, if a QAI makes a life or death decision, can we even ask it why? Okay, I know that sounds pretty scary, but here's the good news. The race is already on. Brilliant people all over the world aren't just sitting around waiting for this threat to arrive. They are actively building the defenses we're going to need to survive in a quantum future.
This quote really just nails the mindset we need to have. In this new world, if you're standing still, you're actually moving backward. Getting ready for what's coming isn't just a smart move, it's an absolute requirement.
So, how do we actually prepare? Well, step one is moving to something called post-quantum cryptography, or PQC. These are totally new ways of encrypting data that are specifically designed to be tough for both regular and quantum computers to crack. It also means companies need to become crypto-agile, which is just a fancy way of saying they need to build systems that can be easily updated as the technology and the threats evolve.
And this isn't just some theory either. People are already drawing up the roadmaps to transition our entire internet infrastructure. Here in the US, the National Institute of Standards and Technology, that's NIST, is taking the lead on testing and improving these new algorithms, creating a safe, standardized path for everyone to follow.
And beyond just writing smarter code, we're also starting to fight fire with fire. There are new technologies like quantum key distribution, which actually use the weird rules of quantum physics to create unbreakable communication channels. Basically, with QKD, if anyone tries to eavesdrop, the very act of looking at the data changes it, and you know instantly that you have an intruder. Pretty cool, right?
So, we've seen the amazing promise, the scary peril, and the frantic preparations. It all boils down to one final, really important question as we stand here, right on the edge of a whole new era.
You know, what makes right now so different from any other time in history is the speed of it all. In the past, we'd get one big invention, like the printing press or the steam engine, and we'd have decades to adjust. But today, we've got quantum computing, advanced AI, biotechnology, all exploding at the same time, and each one is making the others more powerful. And this timeline really shows how fast this is coming at us. Right now, we're in the understanding phase, but in just a couple of years, companies will need to be testing out new security. In just 3 to 5 years, a massive migration will have to start. And most experts think we could hit quantum advantage, the point where these machines become truly superior for certain tasks, in just 5 or 6 years. The time to get ready was yesterday.
Look, this isn't science fiction anymore. This isn't some far-off future. The pieces are all here, and the clock is ticking faster every day. The quantum revolution is happening, and the only question that's left is, are we going to be ready for it?